second, if you.
Yes, certainly.
Do let me know when you start seeing it.
Yes, it's visible now.
Great. Yeah, so thanks again for the opportunity as well to allow me to speak here. My name is Kenneth Matovu. And yeah, I'm going to be basically talking about design patterns that are suitable for the front end, especially for backend engineers. And this talk is mostly going to be about one specific design pattern, right? And what should you expect to take away from this? The first thing you should expect to take away would be how to avoid the front end as a full stack developer. So my background is mostly backend. I think this is the first job where I've taken up a serious role as a front-end engineer. And yeah, I've found it a bit more frustrating than my comfort zone in the backend. And so I'm going to share with you one of the patterns that I found was that has helped me avoid the front end as much as I can. The other thing you expect to take away from the talk is going to be sort of how to accommodate a diversity of front ends. So usually when you talk about front ends, most people think of the PC or the phone, but as you'll see during the talk, the front end becomes wider. It's sort of a very diverse playground. It becomes wider than just wide screens or touch screens. And the pattern I'll be talking about mostly is going to be BFF, backend for the front end. And I know many people will be familiar with that. I will try to, it will be extremely high level. The conversation is going to be extremely high level. I'm not going to try to give examples like of code segments, but yes, feel free to ask questions at the end if any of that is not clear. And at the end, I recommend what I found to be the best thing for front-end heavy engineers as well to avoid a lot of backend. One of the tools that I've seen that works very well with BFF. Yeah, so as I mentioned, my name is Kenneth. I am a software engineer at Genesis, and Gsm Mato is my GitHub. Yeah, so for most of you who are engineers already on this call, I think one of the things that you, if you had a chance of working in a big team, one of the frustrations, if you're specialized either as a front-end engineer or as a back-end engineer, is going to be how to efficiently communicate to the other side of the team. Yeah, and this usually only happens if there's sort of conflicts. If there is, say, if that time restrictions or if there are some other kind of constraints that take you out of the day-to-day harmony. Usually when you're working on a team, obviously it's harmonious, but those small moments where it's not, these are some of the frustrations you're going to experience, right? You have to, for example, the backend developers would always, when you ask for, if you have an API exposed for a certain feature, and the front-end developer today comes and says, we want you to expose the username. Say, for example, it's an API endpoint that exposes user profile. And the front-end engineer today comes, we want you to expose the last name. We're only interested in the last name. And then at 5 p.m. when you're leaving office, they say, oh, actually expose the username and the first name as well. You feel like, telling them, can you guys not plan ahead? And this is a very trivial example, but so this would be in a typical application, it would be something that would require you to actually make a calculation. So for example, if they want you to expose an aggregation, a number of or a count of a certain thing that you have in your database, the ideal response would be, why don't you plan ahead? Let me know everything you need me to expose in advance so I can share this with you, right? And also, yeah, mostly if you don't know a lot about what the front-end people do, you're going to wonder what these guys actually do. If you use the application and you see almost nothing ever changes on the UI, you don't know how much optimization goes on to keep it very, very similar and very, very seamless. So sometimes as a backend engineer, you're going to wonder, yeah, what the hell are these front-end guys doing, right? And it's the same thing with the front end. The front end people sometimes just don't know what they'll need until they need it, right? So they're not like oracles. They're not going to try to predict the future. And when they come to make requests, it's when they know that they need something. And they also don't understand why it is not trivial. If you can expose a username, why can't you expose the number of books the user has read, for example, right? So yeah, sometimes it's just very confusing if you're working in a team that's where the front end and the back end are so decoupled that no one knows what it takes for each other to build their part of the application. Yeah, so this should be the typical front end in Uganda, right? And this is what I was trying to hint on at the introduction of the talk. You have mainly three interfaces, right? In an ideal situation, you'd have to build for three interfaces. You'd have to build for a desktop computer, a widescreen computer where someone has to sit down and interact with you. You'll have to build for a smartphone, a mobile phone that someone can still access some of the basic features that a computer can access, but mobile enough to move with. But one of the other things is you have to also be able to build for SMS and GSM interface. And this is usually for small phones, the all button phones, where someone has to text back and receive messages in order to get just one response, right? And so this is, in this kind of talk, I'm imagining you have a backend that is built or an application that's built, and you want to be able to target these three among, the very many diverse versions of front ends that can be there. It could be targeting an Alexa, for example. It could be targeting a smartwatch. It could be targeting any of the other Internet of Things modules, basically. Yeah. And in this talk, I'm considering all that as front end, sort of a diverse way to target from the backend to target the actual user through whichever device they choose to interact with your application with. Yeah. So if you see, for example, the computer interface, usually the person you interact with the person by either typing. They'll either be typing, they'll either be pointing to click. Usually most computers now have cameras. So if you need to get a video, you're able to see them, and the screen is wide enough so you can sort of display the information in a way, I think as most of you are seeing this presentation, you have a lot of space to play around how you want to display the information. As a designer, basically there's a lot of space when it comes to interacting with someone over the computer, right? And also there are a lot of avenues for data collection, besides pointing to click or typing or video. You can also embed other devices, within the computer. Either if you have a big desktop computer, you can install PCI cards onto the motherboard, or you can use a USB interface to embed multiple devices. So basically, when it comes to when it's a desktop computer, your laptop computer as your front end, you have a lot of options. You're allowed to be flexible as a front end developer, the way you want to think about how you want to interact best with your user. The other interface is obviously the phone. And nowadays, if you have a good phone, it will do almost everything the computer does. It will come with extra sensors that are useful. For example, motion sensors. You can have the phone track your users, and you don't have to have them sort of maybe update their GPS points actively every time. You just have the phone do that for them. So I consider that to be part of what you'd consider as a front end. This is you still interacting with the user. And also the phone is mobile. So the user will put it in their phone and they'll go away from their home, maybe to the shop to buy some food. And if you're interested in that kind of interaction, you will know that my user today, at this time they've left this place to this place. And so when you're thinking about how to design a good front end, you consider all that. Yeah, so I think what the phone brings on as an advantage is that the phone is capable of passively collecting data, sort of interacting with you without actively involving the user himself. And then the third option is the SMS and GSM rather, with these small phones. So here in Uganda, this is not very common anymore, but once upon a time, it used to be a cool thing. This is actually how I started my career. Here in Uganda, there are very many applications where you need to target people who don't have access to a smartphone, for example, right? A lot of innovative, say, medical solutions we have right now that try to offer medicine through the internet, over the phone, or remotely, also rely heavily on devices like this to interact with patients, to collect a list of symptoms, to recommend, to send, say, reminders, say, for example, for pregnant mothers, to remind them on when to take specific medicines or when to report back for check-ins and things like that. Most of those applications rely on devices like this. So you have one application at the back end that is reaching out to the Ugandans within the capital who are able to use a phone or a computer, but it's the same application also that you're using to target people who are using these feature phones. And these feature phones, their interface is so limited that sometimes to have a complete response, say, for example, if you want to get a clear date of birth for the mother, it may be sent over multiple texts. So you probably want to ask them a question: what month were you born, in what year? And then they respond, and then you ask them again in what year, and then they respond, and then you ask them in what, do you remember the day or not? Something like that. So what would have been a very simple form or a very simple way to click on a phone, to touch and move things around on a phone, becomes a process of texting back and forth on these feature phones. Yeah, but that is also still a UI that you have to target if you're interested in these kinds of users, for example. So as I mentioned, I am a big chunk of my career has been as a backend engineer. I've just started transitioning lately to be more full stack. And so I'm still very hesitant to get out of my comfort zone. Yeah. And part of what I'm planning to talk about today is, some of the things that I've done to make sure I still stay within, when I'm building, say, complex applications, I still stay within my comfort zone. I keep all the complexity in the back end and make sure the front end is as simple as possible. So that if I get onto building or, extending the front end, I don't have a lot of complexity to work with. Yeah, and also maybe one of the big things to, one of the big advantages for what I'm going to be suggesting in the next slides is, while at the back end, you sort of have an idea of how many resources you'll have access to. So for example, you know how big your servers will be, how much, say, bandwidth they'll have. Most of those technical resources that you need to know to execute a number of programs, you're not very sure the comfort level of your users. Yeah, you may target a user because of the size of their screen, but you don't know sort of whether they have access to 4G, for example, or they are still using Edge to connect to the internet. You can't control like the resources that the user himself has. Even if they have a computer, you don't know, say, for example, if you used very heavy JavaScript within the browser, you don't know if the computer will be able to handle that. And so since that is out of your control, most of the times the best practices, and you can try and predict and try and target them, the least computer or the least compatible computer, and just know that the ones that are sort of can handle heavier loads will be able to handle. Most of the times that's not possible for you to even predict. So when it comes to maybe using the browser and using computers, that's a bit easy to, there's good data around that. It's a bit easy for you to sort of anticipate what your users will be using. But when it comes to targeting other forms of interfaces, it becomes so diverse, the front end becomes so diverse that it's not making assumptions about how your users will be interacting may not be sort of the best approach to designing a good front end for them. But yeah, and what I'll be talking about mostly will be BFF. This is backend for front end design pattern. I think I saw this once in a talk a few years back, in a talk, I think in one of a webinar like this for Microsoft. And first I initially thought BFF meant design pattern for best friends, but it's not. So what is the problem, right? What kind of problem does this design pattern try to approach, right? Some applications can be accessed through multiple interfaces. Each interface comes with its own requirements, right? Say, for example, Zoom. You can access Zoom from your computer, which I'm using right now, but I can also access Zoom using my smartphone, right? And each of these, when Zoom is trying to design for each user, they're sort of targeting these interfaces individually, right? If you try to go with the option of one API fits all, then you're going to compromise a lot. Either you're not going to be able to exploit all features that, say, for example, my Mac right now can afford to make Zoom work the best it can, or you're going to overburden, say, my phone by making Zoom so heavy for my phone. Yeah. And so the approach of building sort of one API and having it support all the available interfaces is kind of the problem I'm trying to address here. Yeah, in the end, backend requires regular and significant changes to serve multiple interfaces. So this is also one thing is, if you have one API that serves all, if, for example, you're using it to serve the SMS interface and the Android, say, for example, Android phones or iPhones, if say Google, for example, upgrades its API to require permissions to do something that was doing before, you have to go and touch the same backend code that serves the feature phone, even if the interface for the feature phone, the SMS interface, has never changed forever, right? So if you have multiple of those, if it's just not those two examples, if you have many of those others, it means you're always going to come back and modify the backend when one trivial thing changes at one of even the least used interfaces that you have, because otherwise, since all the way you've designed for all the interfaces is sort of coupling, and I think that's the right word. Since it's coupling, then it means that indirectly, a person who uses the feature phone will be affected by an update on Android, even if ideally that is sort of their phones don't use Android, because the application they are using treats an Android phone and a feature phone as the same phone, that kind of backend. Yeah, so this would be like an example of the backend service that is trying to serve, say, for the Android phone and for the PC at the same time. And yeah, this would be, in my opinion, this is not the right way to approach this. The better way to approach this would be a BFF. So BFF basically, I think, is also just a fancy word that ideally would mean set up one service to serve each interface. So if you identify, for example, that a good number of our users access our application through the Xbox, build a service, a client service on the back end that is dedicated to only serving Xbox users, right? If you find out that we also have a certain number of users who access our service through iPhones, target them individually with their own service. And yeah, basically create one backend per user interface, fine tune the behavior and performance of each backend to best match the needs of the front-end environment without worrying about affecting the front-end experiences. So basically, if Android has something that makes the assumptions that were made in the backend before incompatible anymore, that won't affect any other user. And the Android user, apart from the Android users only, because then they will be until rather they get the significant updates from within your API. And so this means that these interfaces seem like they're all talking to different applications, basically. Yeah. And this would be, again, a nice image to illustrate what I mean. You have one service for the desktop, one service for the mobile. And in a typical case, you actually have one service for each mobile OS. And you probably, if you're a big enough team, you have one service for each browser as well. so that you take away any kind of incompatibility. So yeah, when you look at that, it basically, it seems like I'm implying that you should build one application for each. Basically, duplicate your code and have one application for each interface that you'll be targeting. And it could be that's what I mean. It's mostly not what I mean though. The BFF pattern still, there's, I think, the principle called dry and do not repeat yourself. The BFF pattern still respects that principle in the sense that you don't repeat yourself for all the features that are shared by the users of the multiple interfaces, but the features that are not shared, the pattern encourages you to instead look at being more targeted, building an application that is more targeted for those specific users. So yeah, I think the easiest way to think about it is you have an API spec for each interface, for each client. Yeah, and so this may not be obviously a good solution for most people who are also very comfortable with their front end, but as a person who has come from a very back-end heavy history, I want to keep all the complexity within the backend. I don't want to fetch a REST API that would require me to recalculate things within JavaScript to display, or Kotlin or whichever other language to display things on an iPhone. If it's possible for the API to be redesigned to give me just exactly what I need, so I can just sort of focus as a front-end engineer on the interface and serve the data as it comes. So this pattern mimics a lot of the classic gateway design pattern, and I don't know, so there are multiple of those, but if you think of the gateway pattern where you say you have a microservice architecture, in the end, you have a gateway that splits what specific clients you want to target, right? So it would be something like this, right? If you have, say, a contact service, you have a service for, say, orders, you have a service for payments. When these services come together through a gateway, so maybe there could be a third layer here through a gateway, that layer should also be able to, these specific BFF APIs should be able to fetch only the specific data they need from that middle layer just to target the interfaces they want to target. Yeah, so basically, this is what ideally a good architecture would be for a typical BFF application. You have your actual backend, which is very similar, which is shared by everyone. And then you have the gateways that are focused on only what the client would expect. Yeah. And so this also would allow you to separate what would be considered business logic. For example, calculations like how much money do we charge for an item, because that's not specific on where the client is buying the item from, to what would be very client-specific logic. For example, how many items per page do we want to send to the client at a specific time? So yeah, this kind of architecture will allow you to separate those two. Yeah, so question of why BFF, the obvious one is if you serve each interface independently or each client independently, you're more able to support it fully. You don't make a lot of compromises, but also more importantly, you optimize well for each of those front ends. So you don't make compromises on the web because you want your code to also work on the phone. Yeah, also you don't make compromises on the phone. For example, you don't have your application not find GPS because most people are going to be using Macs to access your application, and Mac won't have, well, it does, but probably you're targeting a device that won't have that feature. Yeah, so also the other thing is separating the business logic from the client logic. When you have a team of, when you're working on the business logic, trying to build the application to sort of make sense of the business world or make sense of the actual world, respond to a person paying for an item, or for example, figure out a prescription for a specific list of symptoms. If you're building an application like that, you don't have to worry that your application is going to be dependent on the actual client that's going to try and access it. You build the business logic separately, and then you tackle the client logic itself. How well do I exchange this data between the client and the server? You tackle that problem independently in a way that allows those two kinds of logics to be separate, right? So you have the client side talking to the client, you have the business side handling the actual business logic of the application, and you have all clients satisfied basically. Yeah, also the other and most obvious thing probably, since it's a very diverse, front end is very diverse because there are very many devices, and more devices are being built almost every day. It's very, very hard to be a good front-end engineer all around, right? Usually you're going to be very good React Native engineer, or usually you're going to be very good, maybe Kotlin engineer, or you're going to be a good GSM engineer, or you're going to be very good with embedded systems. You probably know how to say track maybe heat, like track temperature in the house or something like that. Most of the times you're going to be good at just one interface, but not an all-round good. You can be obviously mediocre at all of them. You can, because you know how to code, you can choose to have a hint on what it takes to build for Android, what it takes to build for iPhone, what it takes to build for Windows, and so on and so forth. But you can also choose to actually let specialists do that, right? And yeah, this may mean that I'm actually trying to caution you to be more backend. But what I'm actually trying to say is, if you're strong in the backend as I am, more than you're strong in the front end, even if you're required to do full stack work, you can still play within your strengths. Build a strong backend and focus on the front ends you can do, but have the application always ready for the front ends you can't do when a good front end engineer for those specific front ends comes in. Yeah, okay. So also, when should you do BFF and when is it not the best choice for you? Yeah, obviously, if you assume that your users are going to be targeting your application in multiple devices, if you're working at Netflix, for example, people are going to use the phone, they're going to use computers, they're going to use their PlayStation. If they're going to use tablets, they're going to use almost all the devices in their house to try and access Netflix, then for you it makes sense to try and go with a BFF approach, right? Even if you have few interfaces, but you have interfaces that never change, yeah. So for example, some of the work I do is within SMS, right? SMS has never changed since I started actually programming for it. There is no point in me coupling that code with the code of say Android devices that will change every year at least, right? So if you have, if the rate of change within the specs of the interface, if the rates of change are different, then you still want to go with this approach. So the more stable interfaces also have a more stable API to fetch, to use. And that also, I think, reduces the work a little bit. Yeah. Also, if you already have a microservice architecture setup, which is mostly what everyone is doing right now, if your application is already splitting a lot of the business logic and modularizing that already, then it makes a lot of sense for you to step that up a little bit and modularize the client version of it as well. Yeah, so when not to. If you have a monolith application, then maybe the first step you should think about is how you break this down into microservices. But again, here it's not to say that you can't create a gateway on top of your monolith application. I think it's still possible, but yeah, maybe starting the microservice path would be the better architecture. Yeah, also, if you know for sure, if you're building an interface for, say, for a registrar, like a national registrar, and you know for sure that these guys are given this specific type of interface, they don't move away with the application. They go to office, they sit, they use this specific type of interface and then they go back home, then yeah, I think it would be an overkill. Try and optimize for mobile and try and optimize for SMS if you know for sure that your users will never use that interface. So then it doesn't make any sense to try and go BFF. You can just sort of build your backend and front end the normal way you'd ideally do it. Yeah, so this is the recommendation I had to say. This kind of architecture works very well with GraphQL for people who are more full stack heavy, rather who are more front end heavy, but are still required to do some full stack and get frustrated when they have to query the DB and things like that. Adding GraphQL in your backend as you set it up and using BFF to do the sort of, as your architecture, that also is very compatible. And this is not a very good strength of mine. So I would recommend, I think you'll have the slides after the talk. I would recommend this talk. It's on YouTube. Otherwise, I would have had to do like another 15 slides for this. Yeah, this talk sort of talks about how to get your GraphQL to work well with a backend for front-end patterns. Yeah, well, I think that's all I wanted to share.